Hello and welcome back to the course on blockchain. And today we're talking about cryptography. We're going to understand what role the SHA256 hash algorithm plays in blockchain. Alright, so there's our map and we're starting with hash cryptography. So let's look at a person. There's a person, could be me or you, and we have a fingerprint. And different people have different fingerprints. So if you look at many different people, they're all going to have different fingerprints to us. There is a possibility that there'll be somebody with the same fingerprint, but it is very unlikely. The probability of that is about 1 in 60 million. So in a way, you can say that a fingerprint is an identifier of a person. And that's a very powerful concept which is used by forensics departments in the police, where they can identify criminals just by their fingerprints and take that as evidence to court. Now, what if we could take the same principle and apply it to digital documents? What if we could come up with a sort of fingerprint that would identify these documents for us? And such a fingerprint exists. It's called the SHA256 hash and looks like this. So the algorithm behind SHA256 was developed by the NSA. And I know what you're going to say. You've probably heard the NSA in the news in the past couple of years, and you might have, some, like a great opinion about them, or the opposite. You might not like them, or you might be indifferent to them. Regardless of what is said in the news about the NSA and all those things, one thing they did do really well is this SHA256 algorithm. It works well. It's very secure, and a lot of places in the world, a lot of applications use it to store passwords, to check digital documents, and in fact in blockchain it is used. That's like one of the core principles, building blocks of blockchain, as we will see further down in this section. And the code the algorithm for SHA256 is not secret. It's open, completely open. Anybody can learn it, understand it, how it works. At the end of this tutorial, I'll actually recommend a paper which you can read and understand more about how SHA256 works. Now, this hash is called SHA256 because SHA stands for Secure Hash Algorithm, and 256 is the number of bits it takes up in memory. The hash is always 64 characters long, and it consists, as you can see, not just from bits, but actually from letters as well. That's because it's a hexadecimal hash. It has numbers from 0 to 9 and the letters A, B, C, D, E, F. So there's a total of 16 of them there. So that means each character in the resulting hash takes up 4 bits, because 4 to the power of 2 is 16, and 4 times 64 is 256. That's how these numbers are all linked up together. 64 times 4, which is the size of basically any one of these, is 256. And the important thing to note here is that this algorithm works not just for Word documents or text documents. It works for any digital document or just anything digital. So you could put a video into the algorithm, you could put like text, you could put an audio, you could put an executable file, you could put a whole operating system in there. Whatever you put in there, it will spit out a fingerprint, which is a SHA256 hash. So let's have a look in action. It's great to describe these things and talk about them, but let's have a look in action, see how it works. So we've set up a tools kit for you. It's at tools.superdatascience.com/blockchain/hash. And if you head on over there, let me just go like this, you will see that there's a whole toolkit over here set up. So you can go to blockchain, distributed, and so on. And we'll talk about these further down in this course. But this is what we're going to look at today. But before we continue, there's a copyright notice. We just wanted to make sure that this is not our original code. This was actually created by someone else, created by Anders94. And so Anders Brownworth, thank you very much to Anders for making this available. You can check it all out here, and you can actually add it to your own website if you like. And so here, what you can do is you can input some data, and you will see that it'll come up with a hash. So let's give it a go. So let's say I'll put in hello, this is the blockchain A to Z course. As you can see, this data has this hash, right? And so we're going to explore a couple of things, and after that we'll go back to the presentation and we'll talk about the characteristics of a hash. So right now, first thing I wanted to show you is that if I remove this now and then put it back, it will have exactly the same hash. See, 9944 and then DD11 at the end. So let's remove it again and then put it back. 9944 DD1. So it always will reproduce the same hash if you put in the same data, and that's logical, right? So because like with humans, you take the same person, you check their fingerprint, and then you take the same person, check the fingerprint. It's going to be the same every time. Otherwise, it wouldn't really make sense. You wouldn't be able to use it for forensics. Another thing is that if we change one tiny symbol, like we add like another exclamation mark here, the hash changes completely and entirely. That's called the avalanche effect. We'll talk more about it just now, but the main point here is that making a slight change, the hash doesn't change just slightly, changes completely. You can try like remove the exclamation mark and put a dot, completely different hash. And as discussed, you can put anything here. You'll always get 256. So for example, I've got pasted, copied the first chapter of War and Peace. It's like the biggest book in the world, and this is the first chapter of it. As you can see, I've pasted so much text in here, and the hash again is just 256 bits, so 64 characters. So there we go. That's SHA256 in demonstration. Have a look here if you'd like to play around with it. We're going to go back to the presentation now. Okay, so the 5 requirements for hash algorithms. SHA256 is not the only one. There's other algorithms, SHA256, SHA3, and you could come up with a hashing algorithm. However, there are certain requirements for it to be useful. Number one is it has to be one way. So basically what that means is that you cannot go backwards. You cannot go from the hash to the document. So you cannot restore or reverse engineer the document based on the hash. It has to be like a fingerprint. Like for a human, if you have the fingerprint, you cannot restore what the person looks like. You cannot understand, what color eyes they had or anything else about them. But at the same time, if you have a person, you can always get their fingerprint. So it's only one way. Number two is it has to be deterministic, meaning that if I take the same document, exactly the same document later on, and I run apply the hash algorithm again, I'll get exactly the same result as we saw with that illustration. So these two are pretty straightforward so far. The third requirement is it has to have fast computation, and we'll see throughout the course why that's important. And the fourth requirement is the avalanche effect. And I specifically put an image here because to ingrain this in our memory so we remember that we saw this avalanche on the screen. It is an ultra important requirement of the hash algorithm. So let's see what it implies. The avalanche effect means that if I take exactly the same document and I change, make a tiny little change, even 1 bit of data I change in the document. For instance, we got a +1 over there, over here. So if we do that tiny little change, any change, then the hash will be absolutely different. So we already saw that in the demonstration when we were adding an extra exclamation mark or making some other small changes. The reason it's called the avalanche effect is because of how that is implemented inside the algorithm. We're not going to go into detail now, but you'll be able to check that in the paper if you like. But it basically, that one change triggers a few changes, and they in turn trigger more changes, and they trigger more changes. So it's very smart how it's caused, and it's very similar to an avalanche, where one tiny wrong step can cause snow to start moving, and then more snow moves, and more snow moves, and you get an avalanche. So that's what the avalanche effect is, and it's very, very important in the application of blockchain, and we'll see why when we're talking about mining. In the mining tutorials, in this section, in this module, you'll see why the avalanche effect is so important. And part 5, it must withstand collisions. So what does that mean? What does withstanding collisions mean? Well, it means, like as we saw with people, that sometimes 1 in 60 million, you can have 2 people who have the same fingerprint. And same thing for the hashing algorithm. Because I got the pigeons on the screen already. In a second, so I'll explain what the pigeons are doing there. So with the hash algorithm, as you can see, it's 64 bits, right? So it's very limited. Even though like there's a lot of different variations that you can have, it's still limited. It's not infinite. And yet the quantity of different digital documents that we can create is unlimited, is enormous. We can there's tons and tons of books, there's tons of different photos being created every single day, videos, all this stuff. So in essence, the amount of digital data we have is much, much greater, or we can possibly have, is much greater than the number of variations of a 64 character representation. And so that means that in mathematics is a principle called the pigeonhole principle. That means if you have, for instance, in this case, 10 pigeons and only 9 holes, you're gonna have to put 2 pigeons into one of those holes. There's no way around it, right? So if you have more of quantity A, then there is slots in quantity B, then inevitably there will be what we call collisions in that representation when you try to move from quantity A, which is much greater, to quantity B. So naturally there will be collisions and you can't do anything about it. It's just pigeonhole principle, and that's okay. The thing with that is that it is so unlikely, it is so rare that will happen that we can deal with it. It's okay. It's not going to ruin the algorithm. The problem, just like with humans and fingerprints, we can tolerate that. That's a very rare instance, and it's pretty much a very, very unlikely to happen. And if it's not going to affect anything if it does happen somewhere, sometimes. But with must withstand collisions, what that does mean is that the algorithm needs to be able to withstand artificial collisions that, for instance, pirates can create, and that's a problem. So if you can find a way to create these collisions, to make 2 different documents purposefully have the same hash, that's a problem, because then you can forge documents. Then you might have an important document that, for instance, is who this house belongs to, like ownership document, and it might have a name in there. And if there's a way to forge collisions, to create artificial collisions, then you'll be able to change the name on the document and the hash will be the same. So the person checking the document by the hash will think that you are the owner of the house. And so that's what we mean by withstand collisions. So collisions should not be possible. So there we go. Those are the 5 requirements for secure and safe hash algorithms. They have to be one-way, deterministic, fast computation, the avalanche effect, and must withstand collisions. I know this is quite a lot to take in on cryptography at the very start, but at the same time, this is the foundation of what we're going to be discussing about blockchain. So these things are going to be very, very useful to us. And to finish off, here's the promised additional reading. If you'd like to learn exactly about how the SHA256 algorithm works, then you can check it out here. The paper is called On the Secure Hash Algorithm Family. It's actually not a paper, it's actually a chapter in a book. It's chapter 1 of Cryptography in Context. And that chapter 1 was written by Pennard and Verhoeven. And the link's over there. The link will also be in the notes for the course. There we go. Hope you enjoyed today's tutorial, and now you're well versed in SHA256, and we'll start learning more about blockchains and applying this knowledge from the next tutorial. And I look forward to seeing you there. Until then, enjoy blockchains.